Science with me, Caleb Fleming. Subscribe, like, comment, and hit that bell.
Hey, my science lovers. Today we're going to be shocking salt water. This is called electrolysis. It's really cool. We'll be using a 9-volt battery, and we have copper that we'll be putting into the salt water here. So we'll put these little copper leads into the salt water and shock that. We'll mix the salt into just a little bit of regular water, and any gases that get produced we'll collect in a little test tube, and then we'll check those to see if they light on fire. As it goes along, we'll be watching for any evidences of a reaction taking place. So we'll look for any gases that happen, we'll look for any color changes that take place, and then at the very end, we're gonna try to explain everything that's gone on. This is one that I've really liked over the last couple of years, just getting to think about. So we'll try to think about what picked up electrons at the cathode, what gave electrons away at the anode, what reactions had to happen in order for those two things to take place. And then just recently, I started thinking about this in terms of redox a little bit, oxidation and reduction. So we'll look at just a little bit about how does oxidation and reduction tables help us explain the reactions that we did see take place. So let's jump into it, see what we learned. Hopefully this is really fun for you because it's been really fun for me over the last few years. And what you really should do is there are so many variations that you can do to this experiment. You can switch out the copper for aluminum, you can put different salts in, but there are so many variations you can do to this experiment that are really, really fun. So try it, be safe, don't use too high of a voltage, and 9 volt is probably about as high as you want to get. All right, let's get to ours. Let's go ahead and diagram this out now. We have electrolysis of sodium chloride with copper. And remember, we have our few goals we're going to try to get to, which is how are the electrons picked up at the cathode? What gives them away at the anode? What reactions happen to make that occur? And then some of my thoughts I just started thinking about the last couple days in terms of redox. So if we draw our beaker here with our copper going into our test tube, that's what was collecting the gas. The first thing we want to know is what's going on with water. So water, H2O, so 2 hydrogens stuck to 1 oxygen, covalently bonded there. And sodium chloride starts out as a solid, and it dissolves when it goes into that water. So it becomes sodium 1+ and chloride 1-, both those aqueous. The water is going to split into 2 pieces. A small portion of water splits. It has a cool equilibrium that takes place. So there's hydrogen ion and hydroxide ion. So the hydrogen ion is positive, the hydroxide ion is negative. And that's a small proportion of water splitting. Now we saw a gas forming inside. We saw a blue precipitate that was forming on the other side. And then later on, we had this cool orangish yellow precipitate that started to form. And we also saw that this side, and we'll name them in just a second, started to dissolve. That anode was dissolving. And then the pH, it was neutral. I left off one value. It actually went to 9 for a little bit, but then it essentially hovers around 10. So it goes to about 10. And then later on, the 24 hours later, it's back to about 10. But it did have that little bit of a dip that I'll maybe touch on here. So the electrons, they're leaving my 9-volt battery here, and they're going into our cathode. So this cathode here, you can think about that sort of being negative, and negatives and positives attract. And we'll think about why the hydrogen attracts more than sodium or the copper later on. But the hydrogen is going to, whenever it bumps into this cathode, it's going to pick up some electrons. So 2 hydrogen ions will pick up 2 electrons, and they will become 1 hydrogen gas, and those are the bubbles. Those are the things that made our pop, pop, pop right there. So those 2 electrons create a covalent bond that allow the 2 hydrogen ions to stick together, and they leave the solution. So as they pick up these electrons, they're leaving the solution, and that is called reduction. As you gain electrons, you get more negative, you're reduced. That's reduction right there. So reduction happens at the cathode. And when you have a lot of hydrogen ions, that's what contributes to acidity, and a lot of hydroxide, that's what contributes to base. Now you get more into that later on, but at a base level, that's where we can start. So these hydrogen ions are leaving the solution though, which means we're left with more hydroxide. So we have more base. And to help us understand that just a little bit, when you're a base, in terms of pH, that's a number around 14, whereas when you're acid, that's around 1. Neutral, you're at 7. That's when the pH paper was 7. So we saw the pH move towards being a base as the hydrogen ions leave, so we're left with more hydroxides, those OHs. Now, what's going on over here at the anode? I'll name it in just a second. The copper solid is giving away 2 electrons, and those 2 electrons are going back into our battery. So these negative things, you can think about them, those negatives are attracted to the positive side of the battery. So those electrons leave, the solid copper dissolves and becomes copper 2+ ion, and that's aqueous. And now the positive is attracted to our negative hydroxide, and 2 of these hydroxides can cancel that 2 positive. And when those 2 things stick to each other, the copper ion and the hydroxide, we end up with our cool blue precipitate right there, and that's copper hydroxide. And specifically, it's copper 2 hydroxide, and that's a solid. So that makes the hydroxides leave the solution, so it gets a little less basic. So it reduces the basicness as those hydroxides are leaving the solution and that blue precipitate is forming. So hydroxide's used to make our solid there. And then later on, what started happening?
And this is, I'm pretty sure this is what's happening. You professional chemists out there, correct me. But I think the copper starts losing one electron, and that leads it to dissolving. And as it loses this electron, it becomes aqueous. That one electron goes back, and then the copper is going to combine with our hydroxide, with one hydroxide now. And then the hydrogen is going to leave, and one more copper is going to stick, and we end up with this compound that's orange that I'm pretty sure is copper 1 oxide. So 2 coppers and 1 oxygen, copper 1 oxide. And that's kind of that yellowish orange precipitate. And all that's going on the anode, and we call this process of losing electrons oxidation. So oxidation and reduction, red cat is how you can remember reduction happens on the cathode. And the anode has oxidation. Okay, now here's my recent thoughts. I've just started thinking about this in terms of redox potential tables here. So again, the cathode has reduction, the anode has oxidation. So I was thinking about, why do these things take place? And if we look at our oxidation reduction potential table, we can get a little bit of a clue. So I already got it all drawn and set up here. So oxidation reduction potential. And the key rule that I'm going to use as my guiding principle is, the more positive the value that we're going to see here, the more likely that that particular reaction is going to take place. Okay, so again, our cathode, it's like it's negative because it's got a bunch of electrons on it. And then the anode is like a positive thing. Okay, so the options, what can stick to the negative? We have the sodium can, the hydrogen ion can, the copper 1+ and 2+ can. And then when we look at the anode, we have the hydroxide could stick, the chloride would want to stick, the water could potentially stick to that and give away electrons. So we have all these options of who could stick, and then the hydrogen could also give away its electrons to the anode. So why does sodium not do this? So when we think about sodium, if it were to gain an electron and become sodium, it's hot. That would be a fairly exothermic reaction, but we see the voltage potential there is -2.71. Okay, -2.71. Now let's compare that. What if water gave away its 2 electrons and it became hydrogen and hydroxide? So that would make sense with it becoming more basic and getting the hydrogen gas, which we did see. So it seems like that could be a potential. Maybe that is happening a little bit, but that value, -0.83. Okay, so now what about 2 hydrogen ions? And this is what this table is based off, if you get into it a little bit more, is hydrogen and hydrogen ions. So this is a value of 0, and it explains both of our results. So it's more positive than water, which means that it is more likely than water to do this. So the hydrogen ion would be doing this, getting 2 electrons before water would. Now, what about the copper 2+? Well, the copper 2+, getting 2 electrons and going to copper solid we'll see what our value is for that. That's 0.34. And if we had weighed that copper, we would think that it would get more massive if this was going on. And I probably should have. I bet it did gain just a little bit of mass. Some of that probably diffused over there. So the least likely ones at the top, the most likely ones at the bottom. So we see the hydrogen ion collecting the electrons is the most likely option. And copper, if it made it over there. Okay, so let's look at the anode. What's the likelihood of these reactions? So when we think about chloride from the salt splitting apart, if it gives away 2 electrons, that value is -1.36. Okay, and I have quite a few that I'll jot down. And there's more you could probably jot down for both of these, but I tried to put the top options. So this would produce a yellow gas, which I definitely did not see. So that is one evidence that was not there. So I'm thinking that one didn't happen too much if it did happen. Okay. Now, what about water though? Water would produce, if it gave away its electrons, oxygen gas. It would produce some acid, which would sort of neutralize the base, which we did see. But that's negative, I think that was 1.23, yeah. But we did not see any oxygen. Now what about copper though? Copper gives away 1 electron, that's negative 0.52. Okay, so we're getting down to less negative things, so maybe this is a little more likely to take place. And then when we get to hydroxide, if hydroxide gave away some electrons and produced water and oxygen, we didn't see any evidence again of a gas on the anode. So that probably wasn't happening too much. So very little hydroxide probably giving away its electrons. Now when we look at copper solid giving away 2 electrons, that's negative 0.34. So again, we're moving towards more positive numbers. These are more likely things to take place. And if the copper 1 gives away 1 electron to become copper 2 plus, that's even more likely. And I'll just show that happening right there. And that's a value of negative 0.16. Now, if any hydrogen gas were to make it over to the anode, it's going to have, again, that value of 0. But we separated these, so there probably really wasn't too much gas that reached, any hydrogen gas that really reached the anode. So that probably didn't happen too much, even though it'd be more likely if we were bubbling hydrogen gas on the anode. And same thing with this one. If hydrogen gas and hydroxide were to go on, they're more likely, they're now positive, 0.83. But again, the hydrogen gas probably didn't reach the anode. So let me make some just little checks here so we can see this one probably didn't happen, those two probably didn't happen, but then these two did with our copper giving away electrons. Hydroxide probably didn't happen, we didn't see evidence. The copper probably did, we did see evidence. So let's summarize now all this stuff we just saw. Water splits into hydrogen ion and hydroxide ion, which contribute to the acidity and how basic the solution is. Salt splits into sodium ion and chloride ion, go from solid to aqueous state. The hydrogen ion from the water, 2 of them pick up 2 electrons to be reduced into hydrogen gas, which is flammable. This leaves behind the hydroxide, which makes the solution more basic. Then those hydroxides combine with the copper as it dissolves, giving 2 electrons and later 1 electron. And as they combine, they make that blue copper 2 precipitate and the orangish yellow copper 1 oxide. And all of that allows the electrons to be picked up at the cathode and deposited at the anode. And with the other one, there was a lot. So that was fun. Remember, you got to do science. You can't just watch it. So make sure you go try this and see what kind of results you get to.